I kept getting the wrong answer.
Okay, I just want you guys to look. I am recording, right, because I've had real big problems with this. Everyone can see it says on air recording, agreed? So it should show up later. I've been having, sorry, Cliff, this one, number 13?
Number 13, I kept getting 22 over 5, and then it got 23 over 5.
Oh no, it should be 22, right? 20 plus, yeah, it should be 22. 4 and 2/5 is correct though.
Yeah.
Okay. Nothing else? No. 16, let's take a look at 16. Okay, 16, the last one, usually they get harder and harder, right? So we could assume that 16 might have been the most difficult. What did you do first, Jordan?
That's what I was asking.
Oh, well, what would you, let's just take a look at this. What would your instincts tell you to do first? Do brackets. And even inside the brackets, change all these guys to improper, right? So don't deal with mixed, change to improper. So 10, 11, 12. So I got 12/5 on the outside. Then inside I have 11/3 and 17/5. Okay, so we're kind of just, we've started the question, we've done a lot of work, but we haven't actually even started to combine numbers. So I think of bedmass. Every time I do a math calculation question, I think of bedmass, and I do have work inside the brackets, agreed? But they don't have the same denominator, so I have to pick a common denominator. I usually like to pick the smallest one, which is what the L stands for. So I take the biggest denominator and start counting by 5s in this case. 5 won't work, 10 won't work, because 3 doesn't divide into 10, but 15 works, right? So these guys are both going to be multiplied by 5, and these guys by 3s. I have to change the denominator so it's the same number. So when you have a fraction, if I multiply the denominator by 5, I have to multiply the numerator by 5. You're just changing it to equivalent fraction, so that means you're not changing the value, you're just changing the form of the fraction. Okay, so I'll have a 55 over 15 and 51 over 15. Okay, so now I can actually do my work inside the brackets, which is what the B in bedmass stands for. So when I have the same denominator, the denominator stays the same when I'm adding or subtracting. 55 take away 51 is 4. Okay, so I'm still, these brackets could signify there's multiplication to do, so I suppose this is a positive. You could just look at this, the 12/5 minus 4/15, right? Or you could say I'm multiplying a -1 through. Either way, so I'm going to have to move up here. I have 12/5 minus 4/15, and I'm still not done, right, Jordan? Yeah. So I look at my denominators. I take a look at my largest denominator. Could 15 serve as a common denominator? Yeah, because 5 divides into it. So all I have to do is change this guy to its equivalent fraction form. So this is a little easier than that first job I did. So I have 36/15 minus 4/15. The denominators are the same, so they can be combined. So then I have a positive 36 and -4. That gives me a positive 32. And can I reduce 30 over 15? Can I make it into a smaller equivalent fraction? I can't, because they don't have any common factors, right? So it just stays as 32/15. That's a tough one. Lots of work to do there.
How come we can't just change that 4/15 into, don't you have to like times it by 1? After the, you know, it's 12 over 5, and it's still in brackets, and 4 over 15.
Right, so if I multiply it by a 1, -1 times positive 4/15 gives me -4/15.
So you don't even have to do that.
No, you don't.
Isn't there situations where you have to do that step though?
I guess if there's a negative sign here, I would think negative times negative is a positive. It just depends how you think of that strategy. Okay, so let's move on. We've done all the hard part, everyone, so that's a big yay, right? Just reviewing fractions again and learning how to combine them. So when I'm combining them, the word combining means add or subtract, right? When you add or subtract fractions, this is something that hopefully you take away. So this means add or subtract, or both in a question, right? That's what combining means. So here, when you're combining, we must have a common denominator, right? However, when we start doing multiplying and dividing, you don't need a common denominator, right? You do not need a common denominator because you're just multiplying numerators and denominators, so you don't need a common one. So in a lot of cases, people think, oh, add, subtract is always easier and multiply, divide becomes harder. In the world of fractions, that's not true. Multiplying and dividing are actually, I think, easier with fractions than the adding, because the adding is very precise and nitpicky. You have to have those common denominators. Orders of operation may involve both combining, multiplying, dividing, so that can get very tricky. We're going to talk about decimals today. We're going to do a few things with decimals. We're going to convert decimal to fraction and vice versa. We're also going to revisit rounding. That seems to be another common thing that students struggle with a bit when they come back to school is rounding. And rounding is a big deal in high school math because, especially in applied, we're going to be using technology very shortly, and you'll always end up with decimal answers. So you have to be able to be comfortable rounding to certain place values. All right, now, yep. Oh, what's your name?
Daniel.
Oops, are you in applied 30?
Yes.
Josie, could I give you just, did I give you the right booklet? Thank you. Okay, now the reason it says fractions and decimals, why do you think 7 is called fractions and decimals?
We have to convert.
Sorry, Eunice, I didn't hear you back there. Yeah. Remember I said when we had something like, you can always tell an equivalent fraction, like 3/12 is equivalent to 1/4. And there's a couple ways I could prove it. I could say, well, the cross multiply method, 3 times 4 equals 1 times 12, so that proves it. I could also find the decimal equivalent, right? Any fraction can be converted to a decimal. So this bar does mean division. So 3/12 represents the number 3 divided by 12, which is the decimal number 0.25, okay? 1 divided by 4 is also 0.25, and this is where you can use your calculator. Now we are going to be using calculators more for this little section. So this is really nice. Some fractions become really nice decimal numbers. They terminate, they end, we don't have to round. Some fractions, though, 1 divided by 3 represents the decimal number 0.333 repeating, right? And the 3 goes on and on. So it doesn't stop at a nice place. It's non-terminating, means goes on forever and ever. So that's where rounding becomes important. But these represent the same number, right? They're two different forms of the same number. So that's why fractions and decimals are so closely tied. And what you're going to have to do, you're going to have to convert a fraction to a decimal. Well, that's really easy. You just divide them out. Convert a decimal to a fraction. That can be a little trickier. And then you have to be able to round appropriately. Okay? So, it helps to know when you're asked to round the place value system. So we've included this just as a little reminder. This represents the decimal dot. This is the decimal dot. So after the decimal dot are called the decimal digits, and the place value names after the dot, they're called, they all end in TH. So this is the tenths column, the hundredths, the thousandths, the 10,000ths, and the thousandths. We won't go beyond those numbers in this class, but the tenths correspond to one decimal place, right, or one decimal digit. So this is one decimal place. If you're asked to round to the tenths and you're being asked to use one decimal digit. This is 2 decimals. Sometimes your teacher will say round to 2 decimals or round to the hundredths, but you should know both names. Thousandths is 3, 10,000ths, and 100,000ths. Commonly in applied math, our default is 2 decimals. So maybe we'll add that here. In applied math, and that's the 30 or the 40. If you are not given special instructions, or it's not obvious from the question, then your go-to is, your default is round to 2 decimals. That's how applied math works, okay? And that's in the grade 12 course as well. Now, sometimes you're told, you're given special instructions. They'll say round to 3 or round to 1. The other part you have to watch for is if when we're actually doing application questions, and it says calculate the number of people that would be sitting on the bus. If you get an answer of 2.4, you're not going to respond 2.4 people, right? So you have to round appropriately, right? So that's always given common sense, it's due. All right, so this, interestingly, it's the decimal part of the answer that is what the fraction is made up of, right? So this is the fractional, or the fraction part of a mixed number. Okay, the part that's left over in a fraction is what becomes the decimal. So let's just read this. Decimals are popular because they're easier to type into calculators than money. They don't require any special math program, so it's really easy to type in 0.25. It's hard to type in 1/4 on in a computer, right? Unless you have special math programs. So that's one reason they're so popular. The biggest reason, I think, is money. We express money in decimals, and that's quite common in North America. The cents part of a dollar amount is expressed in decimals. In different countries, they use different money currency, though, so it's not for the whole world. Some currencies don't have any decimals. They just deal in whole units. But in Canada and the States, we do. And decimal numbers are just more easily understood than fractions by most people, what we have found. So any digits after a decimal point represent part of a whole, just like fractions, except in the world of decimals, it's always a power 10 number, which is why we call tenths, hundredths, thousands, 10,000s, 100,000s, okay? So the rightmost digits place value shows which denominator to use when converting to fractions. Digits to the left of the decimal dot are whole numbers, right? So these are the whole numbers. These are the numbers greater than 1. So these represent whole units. These represent parts of numbers. Okay? Now, convert the following decimals to fractions. Reduce your answer to lowest terms if possible. So it is not that, it is kind of easy in one way because this is in the tenths column, agreed? The 5 is in the tenths column. Right? It's in the first column after the dot, so it's the tenths column. So 0.5 could also be expressed as the fraction 5 out of 10. Okay?
You can't just put 1/2.
You can. You would simplify to 1/2, right? You would say what's the lowest decimal equivalent?
That's what came to my mind.
But 0.5 actually represents 5/10. So whatever you were tracking was first expressed as 5/10, and it would become the equivalent fraction of 1/2. Okay? 0.72, whatever you were measuring initially, Cliff, was measured in hundredths, right? Because I see 2 numbers after the dot, so I moved 2 places after the dot, so it's hundredths. So initially it represents the fraction 72 out of 100. It may have been a math test you wrote that the teacher had 100 marks in total. All right, what's the lowest equivalent decimal number then for 72 out of 100?
18 out of 25.
I think I agree with Devin. Can we go lower than 18 out of 25? I don't think so, because 18 and 25 have nothing else in common, right? All right, well, let's see. Let's see if Devin and I are right. I agree with Devin. Okay, well, I know that 72 out of 100 is the decimal equivalent 0.72. Let's see if 18 out of 25 also represents. It should represent, and sure enough, it does. They both represent the same number, right? Or actually, all 3 number forms. 0.72 is the same as 72 out of 100. It's the same as 18 out of 25. So it's not that hard to convert a decimal number to a fraction. It's super easy to go the other way, right? We'll see in a moment. Super easy to convert this to decimal. You just do your division. Going the other way is not so difficult if you know that they're all, every decimal digit is just another power of 10, right? So 255, 3 decimal digits. I have 3, you could also think of it this way. I have 3 decimal digits, right? So I need that many number of zeros in the denominator. 255 is the same as the fraction 255 over 1,000. Okay? Okay, I'm going to give you a moment. It says reduce to lowest terms if possible. Take a minute and reduce that to lowest terms. You can use your calculators. And you can always check if you're right? Because you can do your division at the end to make sure you're... Anyone want to be brave? Okay, so I have 255 over 1,000. I think it could be reduced a little bit.
51 over 200.
Okay, Cliff says 51 over 200. Anyone agree?
Yeah.
Okay, let's see. 51 out of 200. Yeah, 0.255. Good. All right, what about this negative 0.35? Initially, that would represent the fraction negative 35 out of 100.
How would you make that 51 into a decimal though?
You wouldn't. It would stay as 51 out of 200. It's not a decimal.
No, I know, but I mean, couldn't you write it out as a decimal? How come it won't be like?
Okay, if I want to convert this back to a decimal,
Yeah.
it's going to be 51 divided by 200, and it gives me 0.255, what I started with, right? Okay, 35 out of 100. Can it be reduced? Question number 1.
Yeah.
Yeah, how do you know right away that it can be reduced?
5.
Yeah, it ends in a 5 and 0, so you know that it can be reduced by 5s. Anything ending with a 5 or a 0 is divisible by 5. So, 7 out of 20? And just make sure you put your negative sign there. Okay, this one you might jump to its lowest equivalent right away. How would you record negative 15.25?
15 is the whole number.
Yeah, so it's negative 15. It's only only this part that turns into the fraction, right? That's what I was trying to write up here. This is the fractional part. So it would be 15. How do I express 0.25 as a fraction? It's really a quarter, right? Now you might have started off as 15 and 25 hundredths, but that becomes 15 and a quarter, negative 15 and a quarter. Okay? So once again, anytime you're given a decimal digits, they can be just expressed as a fraction over, either over 10, 100, 1,000, 10,000, depending on how many decimal digits you were given, right? 0.35, that would be over 100. Okay, going the other way is a whole lot easier because you've got lots of practice on this. Some of these you know you've seen so many times in your life that you know them from memory, which is great. 1/2 is the decimal number 0.5, right? How about 7/10? Do you know that one?
70 over 100?
Sure, but what's 70 over 100 then as a decimal?
0.7?
0.7, right? Now, it doesn't, these end up just being nice terminating decimals, right? 7 divided by 10. So I'm just going to leave that as a 0.7. I'm going to include the leading 0 here just to make sure you know that it's there's no whole unit numbers. The other thing is in science class, they're very picky about that, so I don't want to lead you into bad habits that you might get scolded for in the science classroom. So I'm always going to write my leading 0. My calculator doesn't, see, and the graphing calculators don't, but I think it's a good habit to get into to write this 0. All right, what about 13 divided by 20? What's the decimal digit associated with that?
It would be negative 65.
0.65. Right. How about 13 over 200?
Negative 0.065.
Yeah, don't forget that 0 in there. It's hard to look at decimal numbers a lot of times, especially if there's zeros after the dot, but don't forget. Okay, so it seems like this is a lot easier than fractions, wouldn't you say? Yeah. All right, let's do some refresh on rounding. Oftentimes, like none of the ones we've been exposed to so far, but you've been given nice decimals to work with. But if I gave you 1 divided by 3, we would get this non-terminating decimal. And that means just because it cuts off here doesn't mean it stops there. It keeps going on forever and ever, right? But I have a limited amount of space in my calculator. So we have to learn how to round certain decimals. When converting from fractions to decimals, you'll often get more than 2 decimal places in an answer. Rounding estimates your answer to make it shorter. Or so we can pick that number up and substitute it into another formula if we need to. To round a number, inspect the digit to the right of the place you want to round. If it is 5 or greater, so that's our rule, and I know there might be some different rules floating around, but that's what most people use. If the next door number is 5 or greater, we increase the digit by 1. If not, the digit alone. So I'm just going to write this down. If the next number is less than 5, so that means it's got to be the digit 0, 1, 2, 3, or 4. Leave the digit alone. That's what they're trying to say here. All right, so this is how we round. Round the following to the indicated number of decimal digits. Check answers with your teacher. Okay, I'll do the first 2 with you, and then I'm going to get you to fill out the chart, and then we'll check each other's work. The nearest tenth, so they're sneaky. How many decimal digits are they asking? 1, right? So that's another fancy way of saying 1 decimal digit. Okay, so this is how I teach it, to start with anyway. I know they only want 1 decimal digit, and they've given me 3. Agreed? So I cover everything up except for 1. Okay? So my answer is either going to stay 17.6, or that last decimal you see is going to bump up one. So it's either going to be 17.6 or 17.7. Those are your only two choices. I look next door, and it's 5. If it says 5 or greater, I bump up. So my answer is going to be 17.7. Okay. Questions? Are we good? All right, the second row asks for 2 decimal places. Okay, so I cover everything except 2 decimal places. All right, so my answer is going to stay 38.12, or it's going to get bumped to 38.13. It's just that last number that gets bumped up. So I look next door. Again, it's a 5, so my answer gets bumped to 38.13. All right, you've got 4 to complete, so take a minute or so, and then I'll go through these. Sorry. Okay, how about the next one? 456.8999. I want the nearest tenth, so 1 decimal digit, right? 1, okay, I'm going to introduce you to a new little shorthand. DD is shorthand for decimal digit, okay? So it's going to be 0.8 or bumped up to 0.9. What's the answer? 456.9, agreed? What about 0.333 to the nearest hundredth?
0.32.
It's never going to go down, Cliff. It's either going to stay as 0.33 or 0.34, but this time I look next door. 3 is a little number, so it just stays as 0.33. It just actually gets truncated, cut off. What does the nearest whole number mean? How many decimal digits? Yeah, 0 decimal digits. So in that case, I would just look at the first decimal digit, right? Is 14.5 gonna bump the 14 up to 15, or will it stay as 14?
15.
It's gonna be 15, agreed? Okay, what about 15.89? I want 1 decimal.
15.9.
Yeah. So that's just a rounding refresh, okay? Same thing here. Convert to decimals with a calculator or using long division. You can use your calculators. Round to the hundredths, 2 decimal places. Okay, so I'm going to give you about 1.5 minutes. You can use your calculator.
I have a question. We're done at 2, right?
Sorry?
We're done at 2.
It's 2:10 actually, yeah. But usually we have break period then, so. Just gonna do a quick, just leave whenever you're ready to go. I'm gonna do a quick attendance, so just wave your arm or yell that you're here. Okay, Jillian, Yusuf, Jerome is here, right? Jerome, Unesa. Nicholas is here. And Blanca is here. Delmar. Jordan is here. Devin and Cliff.
Yeah.
Jordy is here. Tanis is here. Josephine. Here. Nadia is here. Alex is here. And Jeanette. Darian is here. Okay. Just give your name one more time. And what's your last name? Okay, so you just registered, right? Okay, spell your last name. Yeah. And Danielle, just D-A-N-I-E-L-L-E. Okay. Have you taken this class before, Danielle? No. What's your math background?
Pardon?
What's the last math class you took? Do you remember?
Yeah, we're taking math classes in college, civil engineering.
Okay. What, Red River?
Yeah.
Yeah? So this is your first time at our school? Okay. So I'll give you the first book that you missed. This is the course outline. We're just doing some math skills right now. This is the class. Okay, yeah, you can hop on the block and you can look there for some of the videos. I was having problems recording last week, so hopefully we got all those ironed out. Yeah. If you're ready. Okay, so how did we do? Let's try this. 1/3. Okay, well, 1/3, do you recognize what the decimal, even without your calculator? What's 1/3? Yeah, 0.33. What's 2/3? Do you recognize that one from like just math background? It's 0.666 repeating, right? So 0.666 repeating. Maybe I'll do that first. So it would round to 0.33. What does 0.66 repeating round to? 67, right? Don't forget that. 17/8, it's an improper fraction. I know I'm going to end up with a whole number, right? And a decimal equivalent. So this is what I would get initially. This is it ends anyway, so it's a nice decimal. But they wanted me to round to the hundredths. So this would round to 2.13. Okay. 29 ninths. Negative 3.22. Agreed? 7 3/8. Initially, I would get 7.375. That's actually the correct answer, right? If I'm converting in applied, a lot of times they want us to round to get those 2 decimal digits, which changes the answer a little bit, right? This is the exact answer. This is rounded. And then 7 ninths. What does 7 ninths round to? I get this negative 5.77 repeating, right? So it would actually round to 5.78. Yeah? Okay, so there's an assignment to do. It doesn't look like people are having a huge problem. I'll let you work on assignment 7, and maybe I'll walk around and see if people have issues. I think that decimals and fractions or converting fractions to decimals to fractions is definitely easier than doing math with fractions. So work on these 2. Remember, for number 2, reduce your answer to lowest terms. I will start talking about decimals. Maybe we'll do that. See how everyone does. Maybe I'll start talking about them today. If not, we'll do all our work with decimals tomorrow, because we have to do work with decimals, right? We're going to learn how to add decimal numbers, multiply, and divide. Kind of without a calculator and with, just so we know what the calculator's doing. And then we'll start getting ready for your test on Friday. Okay, so on the first two booklets. So if